Welcome to Hart und Trocken. In this video, I want to introduce a core concept of SQL. It is called joining tables. Joining several tables, or so-called joins, is the answer to the question of how can we combine information from several tables. Remember, a relational database typically consists of multiple tables, which are also called relations. In many SQL queries, different pieces of information from different tables have to be brought together in order to build the query result. This bringing together of tables is called joining. In order to illustrate this concept to you step by step, we use a very simple database which only consists of two tables. They are called tools and products. The table tools only contains three columns: ID, name, and count. It also only contains three datasets: 1, alpha 1, 2, beta 1, and 3, gamma 3. The table products is similarly structured. It also only contains three columns: ID, name, and tool. And it also contains only three datasets: 1, round 2, 2, square 1, and 3, triangle 2. Now, an interesting aspect is the attribute tool in the product table. The attribute tool of a product contains the number of the tool which has been used to build this product. So the attribute tool in the product table refers to the tool's ID in the tools table. Loosely speaking, this reference establishes a relations between the two tables, tools and products. Now, a so-called join of two tables is a new table which is based on top of the two original tables. It is graded by putting the word join in between the two names of the original tables. So what in our example is called tools join products can and must be thought of as a new table on its own. Being a table, we can do all the things with it which we can do with any table. For instance, we can select star from it. That means we can select the entire content from it to examine what it contains. So we can type the query select star from tools join products. In fact, the table tools join products is created in the very moment when we execute the query and is deleted afterwards. So if we don't store it explicitly as a table in the database, it only exists temporarily in order to retrieve the answer for the query. Now let's see what the result of this query is. It is this table. Let us examine its structure. On the left-hand side, we find the attributes ID, name, and count, which are exactly the column names of the table tools. On the right-hand side, we find ID, name, and tool, which are exactly the attribute names of the table products. The number of rows in tool join products is 9. 9 is the product of the number of rows of tools, which was 3, and the number of rows in products, which is also 3. The next thing we discover is that on the left-hand side we find 3 copies of the content of the table tools. On the right-hand side we first find 3 copies of the first row of the table products. Then we find 3 copies of the second row of the table products, and finally we find 3 copies of the third row of the table products. Altogether, this is a complete combination where each row from tools is combined with each row from products. For instance, the second row of tools is combined with the first row of products, or the third row of tools is combined with the second row of products, and so on. In mathematics, such a complete combination is called the Cartesian product of two sets. Now, having understood the structure of the new table tools join products, which has been built based on tools and products, let's play around a little with different select statements using this new joined table. For instance, instead of select star, we can select specific columns from the join table Tools Join Products. The result is not surprising, it's the restriction of the result set to the columns count and tool. Obviously, as the joined table uses the column names of the original tables, we can choose any column names from the original tables in our select statement. However, we have to be careful. In this example, we choose name and count from the joined table, both column names from the original tables. However, we get an error message when we try to execute this select query. It says that the column name in the field list is ambiguous. That is not surprising, because if we check back to the structure of the joined table, we find the column name name twice in the joined table, because both tools and products each have a column called name. In situations like these, we may extend the column name by the name of the original table where it comes from. So if you want the column name from tools, we have to put tools dot in front. And if we want it to be from products, we need to put products dot in front of name. Instead of using the word join, we alternatively can also use a comma between the two original tables to be joined. The result is exactly the same. Now, in most of the cases, we are not interested in the complete combination of each row from the first and each row from the second table. Rather, we are only interested in a certain sub-selection of rows in this joined table, rows which have a certain meaning or a certain interpretation. In this example, the key to understanding what I mean is the column tool coming from the table products. For each product, tool refers to the tool ID of the tool which has been used to build this product. So product number 1 with the name round has been built by tool number 2. Product number 2 with the name square has been built by tool number 1, and product number 3 with the name triangle has been built by tool number 2. So in this example, it suggests itself that we filter for only those rows where a given product is combined with the very tool which has been used to build this product. Such a row is, for instance, the second one, because here tool number 2 is combined with product number 1, which has been built by tool number 2. So the coincidence of the value tool and the value ID here is the criterion we want to be satisfied. All other rows where the tool value does not coincide with the tool ID here are not interesting to us and can be filtered out. The filtering in this example I've just explained is achieved by using the keyword on followed by the condition we want to be satisfied. The condition we want to be satisfied is that the column tools in the products table, that was the column on the very right, should equal the ID value coming from the tools table, that was the column on the very left. The on keyword, or as it is also called the on condition, always follows immediately the from part of the statement. So in this case, from tools join products. Now the purpose of this query here is to list all products and their tools. That means we want to list the name of all products combined with the respective tools which have been used to build them. Therefore we select products.name, which is the name column coming from the original table products, as well as tools.name, which is the name column coming from the original table tools. From tools join products, using the on condition that the tool number in products should coincide with the tool ID in tools. The result is what we expect. We get the name of the product round, which has been built by the tool beta. We get the name of the product square, which has been built by the tool alpha. And we get the name of the product triangle, which has been built by the tool beta. So as I said before, the on condition always follows immediately after the joined table itself. The on condition can be thought of as an integral part of the joined table. As the full combination of rows in a joined table without an on condition is of no use in practice, we typically never find a joined table without an on condition. In this select query, the joined table, along with its on condition, can be thought of as a part of the from clause. All other components of an SQL query we already know, like where, group by, or order by, may follow after this from clause. In this example, for instance, there is an extra where condition, where tools name equals beta, which follows immediately after the from clause with the joined table and the on condition. The where clause in this case restricts the product's name to only those tools which are made with tool beta, and the result is as expected. Now let's get some hands-on experience with joining. For this purpose, I have prepared a database containing 3 tables, X, Y, and Z. Their respective contents are completely meaningless. They're just letters and numbers which help us to understand how joining technically works. Here I have opened SQLite Studio and I've loaded a database called Product into SQLite Studio, where you see the tables X, Y, Z are a part of. We can verify that we have the right data in X, Y, Z by clicking on the respective table, and in the tab called Data we can see the contents of the respective tables. So let's click on Z, and in Data we see exactly the values which we have over here on the right hand side. Now if we want to play around with these 3 tables in SQL queries using joins, I open the Sql Editor window and we can type our queries in here. As a first example, I just want to recap what happens if I join 2 of these tables and select everything from the joined table. So I type select, everything is select star from, and now let's join X and Y. That means X join Y. We execute this. And you see that we get a rather lengthy table, which is, as we already said, the full combination of all rows of X with all rows of Y. And the structure of this full combination is very simple. Here you see 5 copies of the first row of X, and here you have a complete copy of Y. And this structure repeats. Here we have 5 copies of the second row of X, and again, here we have a complete copy of Y. And here are 5 copies of the third row of X next to another copy of Y, and so on. As I told you, the full join with all the combinations is not of much use in practice. Rather, the join is combined with an on condition. The on condition reflecting some meaning, some relation between the 2 tables. Typically, the on condition compares one attribute from one table with another attribute from the other table. In our case, that could be, for instance, the 2 letters columns. So you see X1 contains letters as well as Y1. So we could only be interested in those rows where those 2 letter values match. So the first row is a nice one, whereas the second one, AC, should be filtered out. Third one as well, fourth one. The next row where the letters match is, let's see, because here's no B in here, is this one. Row 12, C and C. And the next one is 18, D and D, and there's no more because there's no E in here. So if we choose an on condition, which makes these letter columns match, we expect 1, 2, and 3 rows in our result set. Now let's type that statement. It is select, let's say select star from X join Y, X join Y. Now which are the names of these 2 columns? Well, it's over here on the right hand side. We see it's X1 and Y1. And we want to match X1 and Y1. So there we go, the 3 rows. Let's verify if they are right by looking here on the right hand side. So that first row contains an A, and that row over here also contains an A. So we expect A1, A100. We have A1, A100. Check. Next one is that there's no other A, so we jump to this one here. It's a B, and we look for some matching B, but there's no B in here, so no B matching. Next one here is C, and we look for some matching C, which is over here, so we expect C5, C200 to be a result. C5, C200. Now, D, there's DD matching, so we expect D6 and D300. D6 and D300. And E, well, there's no E in here, so there will be no rows matching with E. Now, typically, when joining, we are not interested in all the columns either, but only in a restricted subset. In most cases, the columns which are used for matching, this is the letters columns in our case, are not the ones which should be output. So let's say that we are only interested in x2 and y2. And we can reflect this in the query by deleting the star and replacing it by x2, y2. If we execute this, you see the same three rows, but they have been reduced to only those two columns, x2 and y2. Now, what I haven't told you yet is that we can also join three tables. Well, this is why we have three tables here in our example. We could join x, y, and z using a nice on condition. The on condition, also something which I haven't told you yet, can consist of more than one criterion. If it consists of multiple criteria, they can be logically combined using the AND operator or the OR operator. So let's proceed step by step. Let's say I want to select everything. We always start with everything from, and now I want to have the triple join of X, join Y, join Z. Yeah? So you just add another join after the first join. And we just for fun look for this. That will be a big combination of rows, but let's see what it gives. So you see it's a rather long table, and that's no surprise because how many rows will it have? Well, it is 5 rows times 5 rows times another 5 rows. So that's 125 rows altogether, as you see here. Now again, no one is really interested in this complete combination of rows. So let's add an on condition. Let's again say we want to match the tables X and Y using the letter columns X1 and Y1. So we want X1 to be equal to Y1. Let's just check what we get here. So see, the table Z is not yet included in the on condition. So what do we get here? If you remember the 3 rows which were our result set in the example before, you will recognize them here on the left-hand side. Here we have 5 copies of the first of these 3 rows. Here we have another 5 copies of the second of these 3 rows. And finally, here we have 5 copies of the third row of these 3 rows. On the right-hand side, we have, as always, 5 complete copies of the table Z. So you see on this part on the left-hand side, the on condition using X1 and Y1 has an effect. However, well, there is no on condition using Z, so that's why we have the complete copies of Z over here. Now let's say that we also want to use the letter column here of Z to do some matching. The matching can either be done with a Y letter column or the X letter column. Let's use X1, and let's say that we are only interested in those rows where X1 matches with Z1. So the first row is one of these valid rows. This one is not valid, not valid, not valid, not valid. And here we are, no, there is no row. You see with C there is no row because we don't have any C over here. And with D, well, there's one row also, which is row 13. So if I add this extra condition here into the on condition, we expect to only get 2 rows, number 1 and number 13. So I add this extra criterion to the on condition using the keyword AND. So now I want to match X1 with Z1, right? So that's it, and I execute. And there we go. We only have 2 rows. It's the DDD and the AAA row. Of course, the letter columns X1, Y1 and Z1 are not the only ones which we can use for joining. We could, for instance, alternatively use these one-digit number columns X2 and Z2 to match the table X with the table Z. So instead of X1 equals Z1, we type X2 equals Z2. Because now we want to have this one-digit column to match with this one-digit column. Let's see what happens. And now it's interesting to see, because we still have the first condition X1, Y1, that the X part and the Y part is connected using these letter columns as before. But now the X part and the Z part is connected using these one-digit number columns. So you see 5 matches with 5, 6 matches with 6, whereas the letters don't match anymore. We could even try to also make the letters match between X and Z. That means I additionally add the one we had before, X1 equals Z1. Now we have 3 parts in our uncondition. The first one matching the letters between X and Y. The second one matching the one-digit number columns between X and Z. And finally the third one matching the letter columns between X and Z. Now let's see what happens if I execute this one. You see there's an empty result set, so I don't get any matches here. The reason is that there are simply no combinations of rows which satisfy all these unconditions. To verify this fact, we loosen the uncondition by taking the last one away and execute once more. That is the result we know already. The third uncondition, the one which I just deleted, demands that X1 and Z1 should be the same. But you see, among those 2 rows, there is no row where X1 and Z1 match. So if I add this extra condition here, there will be no results. However, I could include this third condition, but not using AND, but using OR. So you could type OR X1 equals Z1. Now let's see what happens. Now let's have a careful look at the result. First I have to tell you that the 2 criteria up here, which are connected by AND, are bound stronger than the 2 here, which are connected by OR. The reason is that the binding strength of AND is stronger or greater than the binding strength of OR. Consequently, the uncondition has to be understood as we either get rows in our result set where these 2 criteria are satisfied simultaneously, or we get rows in our result set where this criterion is satisfied. Let's analyze the result set row by row. In the first row we see that X1 matches with Z1, so this part is satisfied. And that holds for all of these, actually 5 rows, A and A, A and A. The same holds for the next 5 rows where we have B and B matching. An interesting row, however, is this 11th one, because here you see C and D don't match. However, C and C is matching and the 5 and 5 is matching. So in this case, these 2 criteria are met and the third one is not met. D, D, these 3 are boring again, because they match the last criterion here. But this row number 15 is interesting again, because D and D match and 6 and 6 match, and so on. It is important to realize that we can change the meaning of the combination of these criterion by putting brackets. If I put a bracket around these 2 connected by OR, the bracket make the binding strength of OR stronger than the binding strength of AND. So the meaning of the uncondition now is that we want this condition to be satisfied and either this one or this one. So either a combination of this one with this one or a combination of this one and this one. Let's execute this one. Let's carefully check these 4 rows. In the first row, you see that A and A matches. This is this first condition. And then we need either to match these one-digit number columns, this one and this one, which is that first. But we see this is not the case here. Or we need this one to be satisfied, which is X1 and Z1. Yes, and we see this one here is satisfied. The next row, again, we always need to have this one with this one. And now we either need to have these two matching, but they don't, or these two one-digit numbers, which match in this case. Third row, again, we need D and D, that's fine. And we need either this one, yes, and no one-digit number matching. The last one, D and D, and here we see E and D don't match, but 6 and 6 match. So again, it's important to beware of the usage of brackets in the on condition. So that's about the technical aspects of joining and the on condition. In the next video, we're going to work through much more realistic and meaningful examples. Thanks for watching and see you next time.